Welcome to another video from Lockdown Electronics with me, Bill. This time we've got a nice straightforward project making use of a Chinese battery testing module to produce a kind of fairly simple but reasonably effective electronic load. So let's get straight to the bench and have a look at the kit. Okay, so this is the Chinese tech that I've acquired from Banggood. It's essentially a device to allow you to measure the capacity of batteries, I guess presumably nickel cadmium or lithium polymer batteries, and it allows you to measure both the current and the voltage, and it records things like the ampere hours, etc. And you can also adjust the amount of current draw and the under voltage point at where it stops doing the test. What I want it for is to make a crude form of electronic load. Now, I appreciate expensive electronic loads have many more facilities than this. However, I don't really need them, and this is something I only need occasionally. So I thought I'd give it a go and get it ordered. So this is the device as it comes in a little cardboard box. Came nice and quickly. And you've got the control unit here with a rotary encoder that also has a push to click, 4 buttons, bit of a display, and on the back you've got the connections to make to the actual batteries, connection for power supply, and then there's this fan which is plugged into the board there. And to enable you to actually assemble this, the board comes into 2 halves, and that'll make a bit of sense in a moment. So I'll just put those to one side for a minute and show you what I've been doing. So I've got this project box that I actually got from Maplin many years ago, and it's been languishing in my parts box, and when I had a look I thought, you know what, that's just about going to fit. So I've very carefully cut out this square on the front. I just used a jigsaw and a file to tidy it up. You don't need to be scared of doing this kind of thing, and actually as long as you're careful about how you do it, you get a reasonable result. It's not a perfect cut out, but it doesn't need to be, because there is a lip on the front module that's going to cover up my imperfections, and I knew there was also room to squeeze in 4 connections, 2 for the voltage probes, 2 for the current probes, and it's going to dissipate a fair bit of heat when it's working hard. So I've got two grill here, which I've just covered with a bit of plastic, which my wife was able to produce from her many supplies for crafting, and actually that's a nice bit of plastic grill, just cover up the hole. And I've got a similar thing at the back to allow warm air to escape. On the top, that pops on there. It's the usual 2-part aluminium project case, and so I've just drilled 3 holes on the top that are just roughly in line with the heatsink. So that's the general arrangement. Now we'll have a look at the assembly. Okay, so what I've done, when I was showing you before, I've separated the two parts. There's just some tags that you just need to gently lift up the plastic, and that'll come apart. One thing to be aware of is that will go on either way, and maybe isn't immediately obvious which way is right. However, the connections for connecting to the battery are on the same side as the rotary encoder, and the reason I've had to do that is because it doesn't matter what you try, you can't actually get that fan through that size hole, so you do need to do that. I was hoping I could just take the fan off, but actually when you do, those nuts come off on those 2 screws there, and you need to be able to retrieve those to put the fan and the heatsink assembly back on. So taking it apart is a relatively easy thing to do. So that goes in last. So first thing to do is to position the front panel into the hole. I'll just show you how that works. Really very straightforward, and the 2 clips are either side, so I'm just going to gently push that in. There we go, and you can see you've got a nice fit. It's snug, but it works. And now all we need to do is reposition the rear part of the module, and as you see, the holes to let the air in are going to be positioned so that they will allow air to be blown onto the heat sink and then extracted out the back. And so final part of fitting the module is to very carefully align those two 8-pin connectors inside the display module, let's call it. That's gone in, seems to have gone, well, I'm speaking too soon there. Yeah, that seems to have gone in okay. And then you just need to gently push, and there's a satisfying click there, and that is positioned. And as you can see, the heat sink is there, so cold air is going to get drawn in and then blown out the back. And the 3 holes on the top, when they sit on there, will take cold air across the top part of the heat sink. So I've already made 4 connections, 2 at the top of a voltage, 2 at the bottom of a current. So that connector just slides on there like that. And I'm always a bit wary of these connectors coming loose, so after I put them in and sold them, I've just put a little dab of super glue on those threads just to lock them, stop them coming undone in service. And then final connection on the module is to the power, which goes at the bottom there, just into that little connector. You can't reverse it, it isn't possible. It says on the instructions that it runs from 6 to about 30 volts supply. I've got 12 volts available here because I've got power supplies for my radio kit, so I've just chosen to use a 1/4-inch jack socket to provide me with power supply for the unit. So let's just power up. There you go, she started up, and you can hopefully see the display. So next job is to put the top on, and then let's make sure that we'll put the top on, and then we'll give it a try out. I have got some plastic feet on order, some quite chunky ones, because I want that to stand well clear of the surface that it's going to be used on, so that air can be drawn in effectively. Okay, so get the top on, and then we'll have a look at the unit in use. Here's the finished article then. I'm still waiting for the delivery of the feet, which I guess will be in the next couple of days, but exhaust port there, inlet ports top and bottom, and nice compact little unit, and I guess it's going to sit on the bench like that. So our next thing to do is I'll get it rigged up to something to produce some voltage, and we can see how the display works. Okay, so now I've got the new electronic load set up to do a little bit of testing. So I've got it attached to my bench power supply, and what I want to do is verify that the readings it gives me in volts and amps are actually reasonably accurate. I'd be happy with 1 decimal place. So I've got the fluke meter here set up to read current, and I've got the east tester here set up to read the voltage, and there's 2 forms of display on here. This one's probably the hardest to see. It's a graphical representation of a battery, and it gives you the information in fairly small font, but if I press F2, it gives me a much larger display, and as you can see there, it's saying 1 volt, no amps. Currently the load is disconnected, so we've got no amps, and we've got 1.02 volts according to the east tester. So I'm happy with that. It's 1 decimal place, and pressing the rotary encoder on the load should switch it on. So you notice that icon there has gone from white to red, and now we're drawing 100 milliamps, and the voltage is dropped ever so slightly to 0.99. So again, we're still about 0.1 of a volt out, but that's perfectly acceptable from my point of view. I wanted to check it at 1 volt because if I want to check some 1.2 volt batteries, I'm going to obviously need that facility. So I'm going to switch it off and just quickly explain the setup to you. So in the setup, we're able to set the current. We're also able to set the voltage at which it will stop, it will automatically switch off. So if you're testing a battery, you don't want it to perhaps completely flatten the battery, you can choose the voltage that it actually cuts off. So I've just got it at 0.83 volts there as I'm just trying out the readings. So I'm going to up the current now to half an amp and just step back out to the display, and we'll switch on. And yeah, our voltage has dropped a little bit, saying not 0.93. The meter is saying 0.94, so it's pretty good. And Fluke is telling me half an amp, and this display is telling me similar 0.50 amps. I'm not too worried about the third decimal place there. And there is temperature display here, probably quite difficult to see. It currently says 36 degrees C, and it also gives me readouts for amp hours and watt hours, so you can actually check what the capacity of a battery is should you wish to make that kind of movement. But all good there at 1 volt. So let's now increase the voltage, and I'm going to just go to somewhere near 6 volts for no other reason than it sort of seems like a good number. So that'll do. That's about 6 volts. So the meter's saying 6.04, the electronic loud's saying 6.03. so yeah, that's okay. We're still at half an amp, and you can see because I've increased the voltage, the wattage has also increased. And I'll carry on again. I'm going to go up to about 12 volts. So there's 12 volts, so about 12.0, let everything settle, about 12.04, that's saying 12.01, so again within 1 decimal place it's fine. Still drawing half an amp, obviously the wattage has now gone up, but what I am encouraged by is the current reading is pretty much been spot on all the way through, so that's good, and voltage is more than adequate for what I need. So far so good. And this bench supply, I'll take it up to its maximum, about 15.1, and yeah, 15.18 on there, 15.1545 on the load, and again we're up at 7.5 watts now. So the temperature's increased. This is the internal temperature in the load to about 43, but it isn't warm enough to trouble it yet because the fan hasn't cut in. Fan's cut in on the bench power supply but not the load, so that's good. So I'm going to disable that. I'm going to go back into the setup, and I'm going to increase the current now to 2 amps, and I'll come back down on the voltage to about 10 volts, and yeah, it's about roughly 10 volts, so that's okay. I'm going to step through here, step out again, so we're at 9.85 according to that, 9.88 on the let's just try and get it a little bit nearer 10. Okay, I'm feeding it 10 volts, and now I'm going to ask for it to check a current of 2 amps. And straight away there's your 2 amps. It's 1.99 according to the Fluke, 2.0 according to the electronic load, 9.66, 9.68, yeah, so that's good. And the fan has now cut in. I don't know how well you can hear that on here, but the temperature inside is 48 degrees and climbing slightly. Now I've restricted the airflow somewhat with my case, so I wouldn't expect it cooling to be perhaps quite as effective as it could be. I may need to make some modifications to the case for that, but certainly preliminary checks appear to suggest that it's going to be okay for the kind of use that I want for it. And I'm going to just increase the voltage now. That won't change the current obviously, but what it will do is increase the wattage. So I'm going to go up to about 25 watts, something like that, so that's 12.2 volts, and yes, the voltmeter agrees with that. 2 amps. So readings are good, but temperature is climbing, and I won't bore you by sitting here and watching that tiny number increase, but It's been up to about 59, but by the time it gets to about 59 degrees, the internal cooling has pretty much got control of the situation, and it sort of holds it about there. If I drop the voltage again down to something where the wattage is probably, say, about 10 watts or something like that, it won't be very long before the cooling starts to be able to reduce this number. There you go, it's already dropping down now. So yeah, that's the load. It works well. I'm happy with the voltage and the current readings. So what I'm going to do now is set up some rechargeable batteries and just see if I can test some of those as a bit of a tryout. Okay then, so here's a little demonstration of the project actually doing what it's intended to do. So I've got it connected to a pair of AA rechargeable nickel metal hydride batteries here. I've had them a few years and I've never been used, and I don't know what their capacity is, so I thought I'll charge them up and just put them on discharge and see what kind of thing I get. So I had a couple of them on 50 milliamps, which is what people reckon is a good discharge rate for a AA battery, and obviously that's going to take a very long time. But just to demonstrate what I've got going on here is I've now put another pair in that I charged up. I've got them on 500 milliamps, so half an amp, and I've told the unit to cut out at 2 volts so it doesn't take the batteries too low, if you see my meaning. It'll allow them to drop 0.2 volts below their stated voltage. It's been on now for, I appreciate you can only see the big numbers really clearly. It's been on now for 1 hour and 16 minutes. That equates to 0.63 ampere hours, and the inside of the unit's up at 41 centigrade, so it hasn't even kicked the fan in. But yeah, so 2.38 volts. It's been slowly dropping down over the last 15-20 minutes, but it's still maintaining the 500 milliamps. I set it to 501 milliamps. That's not a mistake. That's just me not being careful enough. So that's actually quite handy, because if I want to just go away and leave this, the unit will actually take the batteries out of circuit before they get completely destroyed by being over discharged, which is quite handy, and it will keep the information. And I've also noticed that even if you turn the unit off, when you power it back up, it's still got its original information. So that's going to be very handy for me for checking batteries that I use in flash guns and torches, as I use them for diving, and I'm quite keen that the torch does actually work for a specific amount of time rather than just giving up on me unexpectedly. So it's going to be useful for that. But obviously this is a box which can load a device. Maybe it's a power supply or something that you've made, and it can apply a load and allow you to look at how the power supply or a particular block of circuit is performing with that load on. So it's going to be exactly what I want from that point of view. So there we go. That's the battery tester being a battery tester. It is actually possible to, if I can remember, yeah, you also get that display which sort of gives you a graphic of a battery. The numbers are quite a lot smaller, but it's the same information. It's easy enough to see with the naked eye. It's just not quite so easy with the camera. Just see if I can get a zoom in on that for you a little bit. That's about the best I'm going to do with this lens, but yeah, you can see the display anyway. So there we go. So that's finished project. Okay, just to summarise the results of those two tests I did on the batteries, with the current drain of 500 milliamps or half an amp, capacity ended up being about 1.7 ampere hours, and I did a much longer test at 100 milliamps, and I got a capacity of 1.88 ampere hours. So the slightly lower current drain resulted in the batteries lasting a bit longer. So considering those batteries have been sitting in the packet for several years not doing anything, for a couple of charge and discharge cycles they're already up well beyond 1500 milliamp hours, which for me will be good enough for the application I'm going to use them for. Here then is the completed module. I've taken all the wires out so you can actually see it. Got some feet on the bottom, you can see the vents there, and I've got a rear vent here for the exhaust heat to come out of. So that's turned a little Maplin project box that I've had sitting around for years into quite a handy piece of kit, and I'm going to be able to use that now when I'm doing power supply projects, that kind of thing, where I need to supply a specific load at a certain current at a certain voltage. So I'll put a link in the description for where I got this from, and I'll list some of the specifications as well so you can have a look what it's like. But I think that's been quite a worthwhile project, and it's got me quite a reasonable piece of test equipment for not a great deal of money. So there we go. If you've liked the video, please click the thumbs up. If not, you can click the thumbs down. Either way, thanks very much for watching and for your continued support. If you can tell others about the channel, maybe share the video, let people know, and if you've not subscribed, please subscribe, that'll be fab too. And we'll look forward to seeing you on the next video.